Hey audience, let's see this question of Irodov from Hydrodynamics. It's question number 1.317. The question states a pitot tube is mounted along the axis of a gas pipeline. This is a gas pipeline whose cross-section area is equal to S. So this cross-section area, this whole cross-section area is S. Assuming the viscosity to be negligible, find the volume of the gas flowing across the section of the pipe per time in the volume flux. So if this velocity on this section is V, so volume flow rate Q is equal to basically V into S. That is what. So S is given, so basically we have to find this V. If we will get V, so we will get Q. And more thing, and the difference in the liquid column on this pitot tube, so that difference is delta H, and the densities of the liquid and the gas are rho naught and rho. Liquid, for the liquid density, that is rho naught, and for the gas rho. Okay, so let's go to the next page. So first of all, for the gas, and the density is rho here. Alright, so here the fluid is crossing through this section, so velocity here is say V, and the pressure here is, this point is say 1, and this point is say 2. At the mouth of pitot tube, fluid or whatever fluid, gas or liquid, just stops, and that is why it is called stagnation point. You can see what this is: static column of liquid. Do you think that there would be air moving here? No way. So here that is a static air, static liquid. So just before at the mouth of the pitot tube, the velocity is 0, and that's why this point is called a stagnation point. Stagnate, रुक जाता है, stagnation point. So velocity here is 0, and these two are the horizontal points. So when fluid flow is along the fluid flow, a pitot tube is introduced. At the mouth of the pitot tube, velocity is 0. So there is a huge loss of kinetic energy, and that will result in huge gain in potential pressure energy. So pressure 2 would be much more than pressure at 1. So here if I write the Bernoulli theorem between point 2 and 1, so I will write P2 minus P1 is equal to half rho V square minus 0 square. If you're not pleased, I can write one by one, or you can write P2 plus, velocity here is 0, plus 0, height is same, so potential is also 0, and here P1 plus half rho V square, height is same, so we have taken potential to be 0. So P2 minus P1 is half rho V square, and this is air. So in air the pressure varies with kilometers. So if the pressure here is say P2, pressure here is P2, so would be pressure here, that is also P2. And if pressure is P1, so here P1, 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 so here also the pressure would be P1. And this is, there is a liquid, there is a static column of liquid, no movement. So the pressure just above this point is P2, just below that point is also P2. Pressure just above this point is P1, just below is also P1. So between these 2 points there is a pressure difference of P2 minus P1 through a liquid of density, this density was given to be rho naught. So this P2 minus P1 can be written as, in terms of liquid density, so that is a rho naught G delta H. So from here I'll get V square is equal to 2 naught by rho G delta H, and if I take the square root, so I'll get this thing, and we have to find this volume flow rate, in the amount of the fluid volume crossing per time, and that is the velocity times the cross sectional area. So Q is equal to S times of V, so that is S into square root of 2 rho naught by rho into G into delta H, right?